Grand Theft Ucieczki z uprzywilejowanych kontenerów. Brawa! Będziemy uciekać.
Halo, słychać mnie? Ja mam takie pytanie. Czy ktoś miałby przeciwko, gdyby ta prezentacja była po angielsku? Poważnie pytam, bo jeżeli ktoś miałby przeciwko, to możemy ją zrobić po polsku, nie ma problemu. Ale po prostu były osoby, które się... Jest jedna osoba, która mnie poprosiła, żebym zrobił tą prelekcję po angielsku. Więc jeżeli komuś to przeszkadza, to powiedzcie to. Nie, śmiało, w sensie... Okay, so I'm going to make this in English. So basically, the title was supposed, and the topic was, the presentation was supposed to be in Polish, but the slides are all in English anyway, so, because I didn't translate them. So a few words about me. I am currently working as a security engineer at Trail of Bits. I am playing Capture the Flag competitions, which are security-related competitions. I do some low-level stuff and like some reverse engineering as well, and I contribute to some open source projects. And I also have like a blog on the internet, which isn't very active, but anyway. So a few questions first. Who used Docker? Raise your hand, please. Okay, some people do. Who used Docker on production? Raise your hand. Okay. And maybe one more question. Who knows how Docker works under the hood? Raise your hand. Okay, some people think, or maybe they do. I don't know. Like honestly, I think I probably could know more, even though I probably know a lot. So one more question. Is there anyone in this room who understand Docker escapes or a tweet from Felix? Whoever that guy is. Okay, one person, I think. So anyway, let's start with some container lies, because some people say that containers are not lightweight VMs, and I hope that it's obvious to most of you that it's not. So the question is, what are containers? And the thing is that in Linux kernel, there is no such thing as containers, but there are some concepts that build containers. And so the thing we call containers, this is just an abstraction for those things that are there, that are put around processes in Linux. So TLDR is that we have namespaces, cgroups, capabilities, seccomp, and AppArmor or SE Linux, and also some like file system, for example, overlay file system. And I'm not going to talk about file systems today. I'm going to talk about those things and like how to exploit some of this stuff. So anyway, as you can see, there is no magic box called containers here. And those things here are just things that you can like change some attributes over the process. So let's start with namespaces. So namespaces is a concept that allows you to like wrap some global resource and limit the view of a process for that given resource. And those resources can be, for example, PIDs or actually process IDs, or for example, user and group IDs, because there is a user namespace which you can like create for your process. There is, for example, cgroup namespace. So if you are in cgroup namespace, this means that other processes shouldn't be allowed to see the cgroups from other processes. Okay, so let me give you an example for PID namespace. If you are in a Docker container on the left side, and you would do something like copy your bash into my process and launch it, just to make it easy to find this process later on. And if you would list all processes on this container, you would see only those 3 PIDs there. But the thing is that the whole bash process, or actually my process, because that's run here, is actually run on the host machine. Like there is no such thing like guest and host. This is all running on the same machine. There are just like namespaces that are there. And so on the host, if you would like look over the processes on the host and you would try to find this my process, which is a copy of bash, which is running in the container, you would see it over a different process ID here, which would be like 2009-96, right? And on the container, you had it as 26, or sorry, 11. So this is the PID namespace. In the container, you see you have totally different view as a process. And on the host, you can still see this process. You can do anything to it. And this, more or less, this works for all the other namespaces that are there. Yeah, and basically, as you can see, the process from within the container can only see the processes it spawned. So it cannot see anything that's on the host, unless it would be in the same PID namespace as other processes on the host. So the question is, how do you check namespaces? Like, how do you see what process belongs to which namespaces? So the thing is that we have this proc file system, virtual file system, that's mounted in the /proc directory. And so it has a directory for each process. And there is this directory self, which is link for the proc and process ID. And in there, you have this ns directory. And if you would list it, you can see all the namespaces for this process. And so what we can see here is the things on the left are not really important, because as we can see, namespaces says that they are links, like file links. But the thing is that there is no such a file like this. And so we can see there are 7 of the namespaces, which if you would count the lines here, there are 8 lines, but those 2 are exactly the same namespace. It's just some kind of like magic for PID for children. I won't discuss it here, but anyway. And each of the namespace have some kind of ID. So those are unique in this sense that if you have an ID which belongs to a PID namespace, you won't have the same ID for user namespace. But there might be many processes that belongs to the same namespace ID, because that's basically what it identifies the namespace, this namespace ID. And so if you would look over your processes on the host, or, well, on your machine, you would probably have all the processes in the same PID namespace ID, because you don't really run namespaces that often unless some of your tools do. So another concept that is used by Docker is cgroups. And cgroups is a shortcut for control groups. And this is a feature that allows you to organize processes into hierarchical groups. So what does that exactly mean? And also it allows you to control access and limit some resources. Or here I mean like how many PIDs can you spawn, or some I/O devices, memory, and so on. And one disclaimer here, Docker uses cgroups version 1, and there is another version, which is version 2, which is not really used by any tool out there currently, so that's why I'm not discussing it. So I told you that cgroups are built in some kind of hierarchy. So the thing is that if you are on your system, which I can show you like here, this is a Linux box here, and so you should have this sysfs cgroup directory where you should be able to see all your cgroups. And those cgroups are also directories, and there is like a directory tree or hierarchy for each of the cgroup that's in there. For example, one of this is like freezer, one of the cgroup is CPU act, one of them is memory, and so on. And so here we have some example of this hierarchy. We can have, for example, the devices cgroup, and it can have those 4 childrens, like init scope, system slice, user slice, Docker. And for example, Docker creates its own cgroup, because that's like a children of the base cgroup. And so the thing is that in a given cgroup, you have some process IDs. And you can move those process IDs to different cgroups, and you can limit resources here, for example. So you might move all your processes to, for example, Docker cgroup for like devices C group controller, because there are different C group controllers. And so in this, if you would move it here, you can then like limit some resources for, I mean, devices. And so Docker uses it, and for each container, it creates a C group like children, which we can actually later see. Oh, and the thing is that a C group can have 0 or more controllers. And as I said, there's, for example, controller for memory, for RDMA, for this freezer thing is also a controller, for devices, for CPU. And for such a C group, you can have 1 or more controllers attached. For example, systemd creates its own C group, which doesn't have any controllers attached, but it uses it to track processes that it spawns, basically. So it can later like see which processes are in the C group, because whenever the process they spawns another process, it still belongs to like the same C group as its parent. Yeah, and the thing is that if you limit some access, for example, in this like children C group, you cannot really, I mean, this C group cannot have more access than its parent. So if you limit it, the further you are in the tree, the less like resources you can give, as long as you do the limits in all the C groups. So how can you look over the like C groups that are there on your system? You can look by using mount and grabbing for C group. And so the thing is that here we can just see the paths. And this doesn't really matter. You could mount it anywhere on your system. And an important fact here is that if you mount a C group and then attach a controller to it, which is on the right side here, for example, CPU set, devices, speeds, RDMA, CPU act, there are 2 controllers, and so on. So if you attach a controller to a C group, this controller is a singleton. So you might have this particular controller attached to 2 different C groups, and this will be a singleton. So you might, for example, and why would you actually use that? Docker uses it because, for example, on the like main machine, all the C groups are mounted as read-write, and inside the container they are mounted as read-only, which we can see here in a second. Whoops. If I do this here, like check the mounts, we can see that they are all mounted as read-only. This is you from changing the C groups of the processes that are in the container, or like do any other stuff. Okay. As I said, you might have many like here, and you might have known. And this last C group there is from systemd, as you can see. And this X attribute here is not actually a controller. There's like some attribute option passed to the mount. And it just uses the name that's, oh, this C group is from systemd. And we can write it, there because there is the read-write. And as I said, containers mounted read-only by default. And if you want to see which C groups the given process goes into, you can actually check it by cutting the proc self C group. And here, for example, you can see that on the like host machine, right? I'm in like, for example, this is like root or base C group for this like net CLS and net prior. For example, for the memory controller, I am in some kind of C group called user slice. And this user slice C group probably has no limits, but it's still there because you as an administrator could limit this user C group. So that's why it's there. And also you can track the processes that users spawned, right, by this. And so if you want to add a process to a given C group, in this sysfs C group, for example, devices. So for example, here we are in the like base or root C group for the device's memory controller. And each of this C group has different like virtual files that are being spawned here. And as you can see, we have the system slice, user slice, and Docker, and those are childrens of this like slash or base C group, which has this device's device's controller attached. And so we can, for example, look at the devices that are being allowed to be used by the processes that are in this C group. And this here means that, A is like any type of the device. This is like major number of the device, minor number of the device, because all the devices out there have some major and minor number. And there is read, write, mknode. This is not modified, this is mknode, because there is a syscall called mknode for creating devices. So this basically means that since my process, which is like 18392, maybe it's not, wait a second. Are we in the, no, sorry, we are in user slice. So if we go into this user slice C group, as you can see, we have the same virtual files here, but no more children. And so we can, for example, look over C group procs, and here we can see all the process IDs which belong to this C group. And if we would like to move this process to further C group, we could, well, I cannot create any directory here because I'm not root, but if I would go into root, I could, for example, now probably move my process into this, because now in this children C group, we have no processes. If we would try to do it like this, it will probably not work now, but because we are not root. Okay, I would need to move to root and then move this process. But anyway, you can move this process here, and then you can like put some limits over it by writing to this devices allo or devices deni files in an appropriate format, so that then the devices list would also change. Is that understandable anyway? Okay, more or less, I guess. Yeah, so yeah, this is what we have seen, basically. And the next thing that is there on the list of things that, for example, Docker uses is Linux capabilities. And so there is this cool quote that traditional Unix implementations of permissions distinguish two categories: privileged processes, which basically means that you have user ID of 0, which is root, and every other process. And this is no longer true since there are Linux Linux capabilities, because the things that root can do, the permissions that root has, were split into 38 capabilities. And this means that you might have a process which was spawned by root, but it won't be able to do some actions. And those are all of those capabilities. So for example, we have chown. If you don't have chown capability as a root, you can't really use chown syscall. You can't change the owner of a file. And the thing is that Docker grants 14 of those by default. And here is like the full list that Docker grants by default. So if you don't change it when using Docker run, your process, if it is spawned by root inside of the container, it can do all those actions. So for example, it can use kill syscall without like having some permission checks for sending signals. Or it can use mknode syscall. But the thing is that even though you can, for example, use kill, you cannot kill a process that is spawned in different namespace, like PID namespace, because the container is still namespaced, and it doesn't really see other processes from like outside world, I would say. So for example, you also have the set pickup capability by default, which is there to modify process capabilities. But under the hood, you can just remove them. No, you cannot add more capabilities from within the container unless you have, I think, sysadmin capability maybe, or some other. There's this mknode for creating special files, which are basically devices using the mknode syscall. Yeah, and there's, for example, net bind service, which allows you to bind into ports lower than 1024. If you wouldn't have this, you wouldn't be able to do so. You have the chroot, because basically Docker uses chroot under the hood, so you probably need it. It could probably still be like dropped, but they allow you to use chroot anyway. So how do you check what capabilities does a process have? So as previously, there's also one misconception. Capabilities are not given for processes. They are given for threads. And this is actually the same for C groups. So if you have a process that is in the C group, its threads might belong to different C groups as well. So that was a lie before, sorry. And regarding the capabilities for a given thread, actually, there is another layer, which is that you have different capability sets. And there is, for example, permitted, inheritable, effective, and ambient. And honestly, the one that you probably care about is effective, because that's the one that's used by Linux kernel when checking for permissions. The other ones are used, for example, for like inheriting the capabilities whenever you spawn a child process, and so on. So you can, for example, have a process that might have some capabilities, but it might say, okay, whenever I spawn a children, this children must have known all those capabilities. So that's why there's this inheritable set, for example. Yeah, and the others are not so interesting because the one that uses the checks is the effective one. And you can check those capabilities using, again, the proc virtual file system. There is the file called status, which we can see now. So the thing is that this proc self status has a lot of information, like name of your process, its state, like tracer pit if you use ptrace, groups this process belongs to, or those capabilities here below, where they are. Oh yeah, they are here. So my question is, and this value is like encoded in bits. We will decode it in a second. But the thing is, why do I have cap effective? Because this is the effective capability set being 0, which basically means that I have no capabilities. And a guess? I am not root, exactly. So if I would start the process as root, and then do cat proc self status, maybe grab by, cap, then as you can see, we have those bits. And again, any guess why not all the bits are there? Because they are not used, because there are not so many capabilities. So the thing is, if we want to decode it, there is a tool called capsh. Wow, sorry. Which can decode those bits into the capabilities. So I'm currently root, so I have all those 38 capabilities. And if I would start a Docker container, I would have a different number here. So I have actually different capability set, like because Docker doesn't use all of them by default, right? If it would give you all of them, then you would probably be able to escalate and go outside of Docker containers. Yep. So as I shown you, we can decode this value and see all those capabilities with capsh tool. Another thing that Docker uses is seccomp. And this is a Linux kernel feature that allows you to limit syscalls that will be used by a given process. And it allows you to write some seccomp policies which will limit those syscalls. And actually, Docker has its default seccomp policy, which you can see on their GitHub page or in the documentation as well. So let's look over some of the examples that are actually lines from this seccomp policy of Docker. So it starts with default action scmp act erno. And this basically means that by default, if there is no other rule, throw an error whenever calling a syscall. So when there's a syscall that's not being like filtered and enabled by another rule in this policy, this means that Docker won't allow you to use it. Yeah, and in the documentation it says that thread will receive a return value of error when it calls a syscall that matches the filter rule. And the filter rule here, it doesn't really match to any syscalls. It just says, oh, when I'm on those architectures, please use that. Because you might use Docker on different architectures too. So another interesting thing here is ptrace. Because can you actually use ptrace inside Docker containers? Not really, because it's limited by the sysptrace capability, which you don't have. And so this seccomp rule here says that, OK, when we have ptrace syscall, please allow it, but do it only if the minimum kernel version is 4.8. But this is still not really true, because you still lack this capability. But if you would have this capability and you wouldn't be on this kernel version, you wouldn't be allowed to use ptrace, probably. And any guess why? So I wondered about that, and I looked into git blame of this file and looked over the commits there and find out that in 4.8, there was a fix in Linux kernel that moved the seccomp check after ptrace. What it means, basically. Because ptrace is a syscall that debuggers use whenever you are debugging a process, like GDB, for example, uses ptrace. And so with GDB, you can actually catch all the syscalls that are being called by a given process. So it turns out that before 4.8, I mean Linux kernel 4.8, with ptrace, whenever you debugged some process, you could hijack a seccomp rule that would say, OK, I don't allow this syscall. How would you do that? You would launch another syscall, and such a syscall that would be allowed by a seccomp policy, and the seccomp check would pass this, allow you to use this syscall, but then ptrace callback from like Linux kernel would be enabled, and you would be able to change the syscall number in a debugger, the syscall number that would be called by the debugged process. And by that, you could hijack seccomp policies in like this previous Linux kernel version. So they made some kind of like explicit rule that if you use it, oh, sorry, there's another important thing here. They allowed you to use ptrace only with these arguments of null. So probably like ptrace me to check if you're ptraced. Yeah, and they also included it because you could hijack this, right? And as I said, ptrace is also blocked by the lack of sysptrace capability. If you don't have this capability, you won't be able to use ptrace anyway. So another rule here is for all those syscalls on the left side. So for example, for BPF, for clone, for mount syscall, for like quotactl, syslog, setns, unmounting something, or unsharing namespaces. They allow you to do those syscalls with whatever arguments, only if you have this capability, which is sysadmin, which we'll talk about a bit later on. Another thing being used by Docker is UpArmor, and I'm not going to cover SE Linux, I'm sorry. The thing is that Docker uses UpArmor by default, if you use it, for example, on Ubuntu. I'm not sure if it, sorry? Co mówisz, babcia? Okej. Tak, UpArmor ma swoje problemy, ale okay, let's come back. So again, Docker here uses some kind of default profile, which is called Docker default. And it's being like enabled in an enforce mode. And actually, there are two modes of like UpArmor profiles, one of which is enforce, another is complain. Complain is just for learning. It means that instead of like blocking something, it will just log it into syslog, right? or demask. And enforce means that some like rules might block something. And this profile can be seen on the like, actually a template for this profile can be seen on like GitHub. And TLDR is that it denies writing to many special files, for example, in proc file system or sys. And it also denies mount syscall. But the big problem with UpArmor is for doing those actions, like blocking access to like proc or sys, it uses paths. This basically means that if you would be able to make a hard link to proc file system or whatever path it blocks, you would be able to like overcome this UpArmor rule. And you actually cannot make hard links to proc file system, so this is safe in this way, but there might be problems with UpArmor rules like this. And it's a known problem which won't be fixed because there is no good fix for that, I guess. And by the way, regarding the mount syscall, which is blocked by UpArmor, it's also blocked by seccomp and also blocked by sysadmin Linux capability. So does it mean that if I give you sysadmin capability, you won't be able to use mount? Actually, you will be able to do it because there is a special rule whenever you are giving this capability to allow you to use the mount. And we could see it like before, right? So whenever I'm giving you sysadmin capability, seccomp will allow you to use this mount because there is the action allow, right? So if you want to see Docker default UpArmor profile, I would say, what about no? Because it's impossible to see contents of this profile by default, because you can actually see the template in the repository. And this template is generated by Docker. And there was an issue for that. I bumped it like some months ago. Actually, they implemented it recently, so that's not really true anyway. And I dumped this profile on like GitHub too, but because the problem here was that they actually removed this profile after like enabling it, which was like, kind of ridiculous. Okay, enough theory. Let's go to like kind of the main topic, which is like escaping from Docker containers, which have some additional privileges. And let's start with the lamest of things, which is like privileged. Okay, so who knows how to escape from privileged? Raise your hand. Okay, so actually, let me do it. So what actually this privilege do? It gives you almost full privileges in your Docker container, which basically means no UpArmor, no seccomp, and all Linux capabilities. So if we launch a Docker container with privileged, and then now look over cat proc self status, we can see that like this value was there on the host when we were on the root, right? So this means we have all the capabilities. There is seccomp 0, which basically means there is no seccomp policy. And maybe I can also show you that we don't have UpArmor because it's also here. It's, I think, current. Unconfined here means that there is no UpArmor policy on this, like, enforced on this process. So what can I do now? I can, for example, take the SDA1 device that is there, mount it in TMP, and then make a chroot there. And I am actually on the host machine where, oh, wow, I have, for example, flag.txt file here, which I have no idea what is the content. But anyway, so I actually escalated to the host. But is that like 100% true? Not that much because, well, yeah, I can do anything. I can hijack all the machine from here. But I'm still, for example, in another namespace, which is hard to show, but because we would have to compare two different processes with their namespaces. But we can, for example, see that we are still in the, wait. Oh, because I used chroot I don't see it here, but if I go out of chroot, I can see that I'm still like in the C groups being spawned by Docker, but those C groups doesn't limit anything. And I'm still in namespaces being spawned by Docker, but those namespaces doesn't, oh, maybe they does limit view. Yeah, you can, oh, sorry. It should be like this, right? I'm with privilege, and I don't really see other processes because I'm namespaced. But since you have privilege, you can go outside of namespaces as well, which is not that important because if you can mount the hard disk, you can do anything. Another thing is that you don't actually need privileged. So this is a bit different. If you would allow someone to launch arbitrary Docker run commands, and you would somehow limit launching privileged, then they could just mount the root path into, for example, tpath, and then do the chroot there, and then, for example, look at etc shadow and change this file, or add some cron policy, right? So, but this is anyway boring. Why is that boring, and why do people care about such examples? Because if you would look over some Reddit topics about Docker escapes or Twitter topics about Docker escapes, a lot of people show examples that works on the privileged flag. So, yeah, as I told you, this is not exactly 100% escape, but you still can hijack the whole machine, so kinda yes. And yeah, we are still in separate namespaces and specific C groups, which have no limits, except of namespaces which limits your view. And why does anyone care if you can hijack the root file system? Any idea? I have no idea. So my point is, let's see something else, because that previous example was kind of boring. And here is one escape from Felix Wilhelm, where he shown an escape actually, and he told oh, this works on the privileged containers. But my question was, who the hell cares about privileged containers? So the real question that should be asked here is, what are the permissions that you need to actually launch this and go escape from Docker container? Because that's important. Because if you can do privilege, you can do anything, right? So the question is, what privileges do you need? And the answer is, you would actually need to add the sysadmin capability and also disable UpArmor. And we will see it in a moment. So one note about sysadmin capability. Previously, we could see the seccomp policy for it, where it allowed a lot of syscalls. And the answer for that is, if you look over man capabilities, there is a huge list of things the sysadmin capability allows you to do so. Because the problem with it is, if you scroll further in the man capabilities to some notes for kernel developers, they say if you add some new, if you want to add something to, if you want to add something to a capability, please don't choose capsysadmin, because it actually has a lot of things, and it can plausibly be called the new root. Because probably if you have this capability, you can escalate to gain more capabilities. So let's get back to this POC, which was super ugly. And here it's in a prettified version. And a little modified version, but it doesn't really matter. But the reason for the modification is that since we don't use privileged, there is another thing that we have to do. So let's demo that. OK, I have this run sh script, which actually runs a Docker container on Ubuntu image, launches bash. It adds this sysadmin capability. It uses the security opt UpArmor unconfined, so basically disables UpArmor. I'll just run it now. And let me see the POC, because it's not so easy to remember that. So the thing is that we actually, how this exploit works, it will use some kind of feature of C groups where you can send notifications to when you can have, there's a feature called notify on release in C groups. This feature allows you to specify a process which will be spawned like as a real root on the host machine, whatever that means, whenever the last process leaves a given C group that enables these notifications. So can we normally use this feature inside of a Docker container with default settings? No, we can't, because we cannot write into the C group file system. And here we have to do it to override some settings. So since I launched this container, we can see that I still cannot write anything into any of the C group because they are still mounted as read-only. But because I disabled AppArmor, which prevented me from using mount syscall, and I also gave to myself the sysadmin capability, which also prevented me from using mount syscall, but since I have it, I can use mount syscall, so I can mount file systems, for example. I will just remount this C group file system as read-write, actually mount it once again. So here, I have this directory, tmpc group x. So maybe let's call it xx. Well, probably need this. Sorry. Okay, anyway, I created this tmpc group, then I mounted the C group file system with the RDMA C group controller. This does not necessarily mean there are many other controllers which would work here. So this is just the name of the file system that I will mount. And the path that I mount into is the tmpc group. Then I'm creating a child C group with mkdir, which apparently didn't work here because the -p was not on the left side. But anyway, I still have this X, but maybe let me create a new one. Okay, and so I have a clean C group here, which doesn't have any processes in it. And there is this file called notify on release. So this is this feature. If this file contains 0, this means it's disabled. But since I remounted the C group called the C group controller RDMA as read-write, which is here, I can write to this file and override this setting. And by the way, as you can see, I have this RDMA controller mounted twice, and one is read-only mounted by Docker, and one is read-write mounted by me, because I could use mount now. So anyway, I'm going to write into this notify on release 1, so that I will be able to use this feature. And now I need some kind of set magic from etc/mtab. So let's see over etc/mtab. Great, I don't have vim in Docker container. V as well, this is bad. So the thing with etc/mtab is that it has the mounts that are being done, right? And it actually shows you the real path on the host machine that the container uses. It's somewhere here, varly docker overlay 2 L something. I think it's actually here, because there is this probably container ID or image ID or something like this. And there is this div directory in which if you write to this directory, this means that you write to the root path of the container. So I can actually show you this, but first I will grab this. I will grab this this path to the host path. So just to recap, I made some kind of set over this etc/mtab. Let's not discuss what it's here, but basically I retrieved the path here. And this path, just to show you, if I copy it and use the host, and be on the root side of things. If I create some kind of file there, this file should be inside of the container, as you can see. I created it on the host. This is host, root Ubuntu. Not sure if you see. I created a file with touch in this path, and it's there in the container. So whenever you are doing something, whenever you're making some changes inside of the container to files, those files appear on the host file system because they have to be somewhere, right? Okay, let's come back to the exploit. So I have this host path, which I retrieved from within the container, which is kind of weird. I probably shouldn't be able to do so, but I can, because it's there. And so now, in this TMP group, in like the base C group, and we are actually exploiting here some kind of weird setting of Docker that, if you look over the C groups, oh, sorry, I have to show it like this. So, if we look over the C groups, all the C groups controllers, except of RDMA, has this Docker, the container ID. Basically, the C group path is this Docker and container ID. And for RDMA, we are in the root path of the C group controller. And in all of the root paths of the C group controllers, there is this release agent virtual file in which you put a path to a file that will be to a program that will be spawned on the host whenever this notification event is being triggered. So now I can put here some path to a binary that the Linux kernel will use to spawn a process whenever another process leaves some C group of this RDMA controller, like a child C group. So, okay, let me do something like this. I will now create in my root path a file called cmd, and I will start creating some shell script there. And this shell script will use PSAUX to list all the processes on the machine, and it will save its output into the host path into output file. And yeah, I saved this script into the CMD. So we can see the CMD here. It's easy. This is the path because it was retrieved by us, right? Now I need to oops, why is it okay? To give it permissions. And now I'm going into this XX C group that I created, and here there are no processes. But since I am root and I have this sysadmin capability, and I'm allowed to, and also the C groups are are mounted as read-write, I can actually move a process to a given C group. So I can move this process that, maybe spawn another process will be sh, and as its comment, I will do echo $, which means basically show the process ID of this sh process. And I will send this into this C group procs. So what will happen now if I press enter? The sh process will spawn, it will show this $. This will be piped into the C group procs. So this basically means this process will be moved into this C group XX. Then this sh process dies, which triggers the notification. And since I have this notify on release as 1, let's see if I have it, because I'm not sure. Yes, I have it as 1. Since I have it as 1, the release agent will be triggered. And this release agent says, okay, take this long path to this container root path on the host and spawn a process spawn a binary that's there, which is CMD, or actually shell script here. And this CMD, as you could see, had this okay, launch PSAUX and save me the result into the container. So in this long path, now I should be able to see output. But this path is on the host, so I don't really see this path here. But this path here is on the root path, and we didn't see it. I don't know why.
Quotation was after the echo.
Oh yeah, you are totally right. This was wrong here. It should have been like this. So now we don't see either
I showed this the ID of the
You mean this ID would be wrong?
the container ID maybe wrong. See,
Oh, like here. I think it is probably wrong because we could have seen different one, right? Let me copy this once again and maybe echo it. Yeah, this path is wrong here. So maybe I'll just do this again. Yeah, but it's not correct now. I need to recreate the CMD script. So now it has the correct path. Now if I do this sh magic, which is not easily accessible here. Yeah. We can see the output here. And this output is the PS on the host, spawned by root. I probably should have like do ID there or something like that. But basically you can see all the processes there. If we do it here, we wouldn't be able to see it because we are namespaced and we are limited by all this shit, right? So this is one example of escape, and another one could be actually mounting a disk device by first creating it with mknode, then mounting it. And the problem is that C groups by default limits us to like mount this device. So this would fail, but since we can use mount, we can mount the C groups as read-write and allow ourselves by writing to this devices allow with like allow to mount any block device. Then we can mount it, then we can see it root, and we can hijack it. Some random extras if you want to make your Docker container insecure. Here are all the flags you need. Except of one, which is there is no flag to say, oh, please use the mount from the host, but you can use the bind mount volume for that. So anyway, this is not so important, but the slides will be on my blog, by the way. And there are some security flags as well, but you should probably know that if you use Docker. And to sum up, the containers are pretty complex. And there might be other escapes like this, maybe without some additional like privileges. And there are many resources on the net. One of the good ones is like from the Black Hat from this year, which is probably wrong link here. Another one is Understanding Docker Container Escapes, which basically explains all these things that I showed you here, except of these things that Docker uses under the hood. And thank you. Any questions?